Hello and welcome back. This is our third topic under blood. We're talking about blood disorders. This is blood safety. These are not disorders, but they are conditions or diseases that are spread through the blood. And so you want to be sure. So you want to be sure that if you're in the medical field, you're probably going to get more training on this. But if you're in the medical field, you want to make sure that you stay away from people's blood because these are conditions or diseases you can get from people's blood. So there's some more information, read and take notes, and then avoid contact, of course. These are the ways that you avoid contact with blood. Carbon monoxide, it's important. It's called a silent killer. So, take whatever notes you need from this and go and read this article. Anemia, you've probably heard of that. It's important because you need iron in order for your hemoglobin to form. And if you don't have enough iron, you're going to be anemic. This kind of sickle cell anemia is the one we're going to talk about now. So I want you to take some notes, and then I want you to go watch this video. It's about the link between malaria and sickle cell anemia. It's very interesting, has a lot of genetics in it. I think it's very relevant to what we're doing now. So it's actually codominant, and we're going to do some genetics questions here in a minute. And so you have big A is homozygous dominant, little a is homozygous recessive, and that person has sickle cell anemia. And then these are just carriers if they're heterozygous. All right, and so I'm going to explain. Let's see. This first one. All right, so the question says, a female who has sickle cell anemia is married to a man who appears normal and the doctor says that he's normal. So we're going to do our Punnett square. The thing about sickle cell anemia is that it doesn't matter whether they are male or female because it's not sex linked. So you're going to do your Punnett square, your female who has sickle cell anemia and the normal male. Big A, little a, big A, little a, and big A, little a. Okay? And so what we see is that they're all carriers, but there's 0% chance of their children having sickle cell anemia. Okay? And our second question, our next slide, what happens when a female who is a carrier marries a man with sickle cell anemia? Okay? So again, it doesn't matter male or female. So we have a female who is a carrier marrying somebody with sickle cell anemia. Okay, and so what we have here is that we have a 50% chance of an affected child. Okay, let's go back to our presentation. All right. So we have some other information about it, and then I want you to take this quiz, which is going to be on mostly on the video, but it has information about sickle cell anemia. So take that quiz for a daily grade, and then come back. Leukemia is a type of cancer, has to do with your blood, so read through that, take your notes. You can go and Google and find some more information if you need some. Mono, again, the same way. Read through that, take your notes, see how it relates to the blood, and then there's another article if you want to go through and read that. Let's speed through this one. You can study it if you want to. Hemophilia is what we're going to talk about now. We're going to talk about the genetics here too. It's where your blood doesn't clot. You can bleed to death. Especially a long time ago, you bled to death. Queen Victoria was a carrier. And Queen Victoria and Prince Albert were king and queen. She was a queen of England, and they had a bunch of kids, and they married their kids off to all the royal houses of Europe. And if you know a lot about world history, which some of you probably do, you recognize some of these names and all the terrible things that happened to them. Somewhat as a result of having sons with hemophilia. Okay, so you can all trace it back to Victoria. Either she had a mutation or something like that. There's a lot of controversy about how this arose in the royal houses of Europe, but started with Queen Victoria. So females, if they're okay, so this is sex linked. It's carried on the X chromosome. And hopefully you remember that females are XX and males are XY. Okay? So females are normal, big H, big H. If they're a carrier, big H, little h. And females can be a carrier. They can have the little h and still be unaffected, okay, and still be normal, still appear normal. Their phenotype is normal. But then females have to have two little h's in order to be hemophiliacs, okay? Males only have the one X. And so if their X is affected, like here, then they are a hemophiliac. Otherwise, they're normal. All right, so let's look at some problems. All right, so insert a new page. Okay, and so it says, what happens when a female who is a carrier marries a normal man? All right, and so this matters with females and males, right? So female and male, so we'll start with that. And so our female is a carrier, and so we know she has a big H and a little h, marries a normal man, and we know that his H is normal, okay? So X and X, big H, X, big H, X, little h, X, big H, and a Y, and X, little h, and a Y. And so we have is that the females are going to be normal, okay? So so each daughter has a 50% chance of being a carrier. Carrier female, okay? And each son is a 50% chance, 50% affected male, okay? Because it makes a difference with males and females. In order for a female to be affected, she has to have two little h's, but a male can be affected with just one h, one little bitty h, okay? And so the next slide, what happens when a female who is normal marries a man who has hemophilia? Okay, so again, our X and our X, and our X and our Y. Our female is normal, so she's going to have big H's, and our male is affected. Okay, so let's do this one. X, big H, and a Y. X, big H, and a Y. And so what we see here is that all daughters will be carriers. Because the male, the father, is going to give his X to each daughter, okay? And his X, he only has one X to give. Females have two X's to give, and so it's kind of random. It's random on how that is sorted down. But males only have this one X to give, and so all the daughters will be carriers, and the sons are fine. Or the sons are normal because their X came from mom. Okay, here the sons could be affected because mom had an affected X. And let's go back to our presentation. We did that. Okay, jaundice. Okay, so read through that, take your notes as necessary. And then that's the end, and we're going to do some case studies, and I'll have more information at the end of this slide.